I'm Dr. P. Usha Rani, Professor EEE Department, RMT Engineering College. I'm going to brief about the topic of absolute error. Actually, absolute error is basically so many types of errors are there. This is due to various reasons. One is due to faulty equipments, that is not working condition, and you can say human error also. It is very much essential to reduce these errors to enhance the precision of the results. For that only we are going to find out absolute error. Okay, here the formula for absolute error is the difference between the measured value minus the true value. True here is actual value. So AM minus AT as the absolute error. If you need correction, you have to take the negative sign of the absolute error. And third one is relative error. Relative error is the ratio of absolute error to the actual value or the true value. Okay. So we are going to find out absolute error. For example, I have considered the question as a voltage has true value of 1.5 volts. An analog indicating instrument with a full scale range of 0 to 2.5 volt shows a voltage of 1.46 volt. What are the values of absolute error and correction? Express the error as a fraction of true value and the full scale deflection. That is the given question. So we have to find out absolute error. The formula for this is AM minus AT, measured value and the true value, difference between that two. Correction as negative sign of absolute error. And if your fraction of this, if you want to find out relative error, you can find out ratio of what are the calculated value of absolute error divided by the true value. Okay, so we'll see how we are solving. Okay, the true value given in the question is 1.5 volt. The measured value AM as 1.46 volt. The full scale deflection range they have given us 2.5 volt. First question, we are solving absolute error. The formula for that is epsilon naught as, which is the difference between measured and true value. So I have substituted AM minus AT. In AM value as 1.46 and AT value true or actual value, that is 1.5 volt. So I am getting the answer as minus of 0.04 volt. That is my absolute error. Okay. Next is correction, as already I mentioned the formula, which is a minus of absolute error. So minus epsilon naught. So we will be getting the answer of absolute error as minus 0.04 volt. So the answer for correction is 0.04 volt. Next is relative error, epsilon r. Okay, relative error formula is absolute error divided by true value. So we have substituted the value of measured value as 1.46 minus of actual or true value as 1.5. The difference between that as absolute error, as already we have calculated, minus 0.4. Okay, and actual value or true value as 1.5 volt. So I have substituted that. So my answer for relative error is minus 0.026. 0.026. Third one we have seen. Next, fourth one we are going to see that as error as a fraction of full scale deflection. Here the full scale deflection here is given as 2.5. Previously we have relative error, we have calculated AM minus AT, that is absolute error divided by true value. Here they have given full scale deflection value, that we have to use instead of the true value. Okay, so the absolute error we have calculated as AM minus AT, which is 1.46 minus 1.5, that value is minus 0.04. divided by full scale deflection given in the question as 2.5 volt. So I have substituted 2.5. So my answer for that is minus 0.016. Thank you.